Hello everyone, the topic of today is queuing theory. Now in our day-to-day life, we often come across problems where we might have to wait in line or wait in queue to get a product or to get some sort of service, right? So there are many situations where we have to stand in queue to get a service or to get a particular commodity. For example, now if you have gone to a bank, then already if there are many customers who are getting serviced, so you might have to stand in line to get your service, to get your banking operations done. Similarly, if you are visiting a doctor and if there are already many patients in the clinic, so again you might have to wait to get your service done. So there are so many examples. Even if you are going at an ATM to withdraw some cash, already if there are many customers in the queue, so you again will have to wait in line to withdraw cash from the ATM counter. तो इस तरह के काफी सारे एग्जांपल्स हैं, चाहे वो बैंकिंग सिस्टम हो, रेलवे रिजर्वेशन सिस्टम हो, डॉक्टर्स क्लिनिक हो, राइट, और इवन इन अ गैराज इफ यू हैव गॉन टू गेट योर कार सर्विस्ड and if there are already a lot of cars who are getting service, so you might have to wait to get your car serviced. तो इन सारी problems को deal करता है ये chapter which is called as queuing theory. Now queuing theory deals with the optimization of costs related to waiting line or queuing line. This queuing model was developed by Erlang in 1909. And the purpose of it was to reduce the costs related to waiting line, right? Queuing से related जो भी costs है उनको optimize किया जाता है यहाँ पर. And this chapter deals with minimization of costs and simultaneously reducing the waiting time of the service. Over here, there will be two variables which will be constantly used. One, arrival rate. Another, service rate. Now arrival rate will be denoted by lambda and service rate will be denoted by another Greek variable which is mu. तो यहाँ पर दो टर्म्स लगातार यूज होंगे, एक तो अराइवल रेट जिसको कि डिनोट करेंगे लैम्डा से और दूसरा सर्विस रेट जिसको डिनोट किया जाएगा म्यू से, right? Now arrival rate is the rate at which the customers are coming in the system. Right, so the frequency at which the customers are entering a system is denoted by lambda, and this basically rate is called as arrival rate. Service rate is the rate at which the clerk who is sitting at the service counter can provide service to the customers. सर्विस रेट जिसको कि म्यू से डिनोट किया जाएगा, सर्विस रेट का मतलब है किस फ्रीक्वेंसी से वो जो क्लर्क सर्विस काउंटर पे बैठा हुआ है वो कस्टमर्स को सर्विस प्रोवाइड कर सकता है. तो यहाँ पर दो टर्म्स यूज होंगे, एक तो अराइवल रेट जिसको डिनोट किया जाएगा लैम्डा से और दूसरा सर्विस रेट जिसको डिनोट किया जाएगा म्यू से. Moreover, in this chapter of queuing theory, you will also be finding out the waiting time of a customer in the system, number of customers who are waiting in the queue as well as in the system. तो यहाँ पर हम वेटिंग टाइम भी कैलकुलेट करेंगे, साथ ही साथ कितने कस्टमर्स वेट कर रहे हैं वो भी कैलकुलेट किए जाएंगे और उनकी हेल्प से आगे चलकर मैनेजमेंट ये भी पता लगा लेगा कि कौन सी सिचुएशंस ऐसी हैं जहां पर हमें एक एक्स्ट्रा सर्विस काउंटर क्रिएट करना पड़ेगा जहां पर फ्लो ज्यादा होगा कस्टमर्स का, right? So to avoid dissatisfaction in the customers, we might have to create one more service counter for the proper service of customers. और कभी-कभी ऐसा होगा कि सिचुएशंस डिमांड करेंगी कि जहां पर कस्टमर्स का फ्लो ज्यादा नहीं होगा, तो वहां पर ऑलरेडी जो सर्विस काउंटर्स हैं उनमें से कुछ सर्विस काउंटर्स को रिड्यूस करना पड़ेगा. ऑब्वियस सी बात है, जहां पर रश ज्यादा है उस रश को केटर करने के लिए आपको एडिशनल सर्विस काउंटर्स लगाने पड़ेंगे और जहां पर रश कम है, जहां पर फ्लो कम है कस्टमर्स का, वहां पर आपको सर्विस काउंटर्स कम करने पड़ेंगे क्योंकि जो एग्जिस्टिंग सर्विस काउंटर्स हैं उनमें से कुछ ही सर्विस काउंटर्स उन कस्टमर्स को हैंडल कर लेंगे. सो इफ द रश इज मोर, इफ द फ्लो ऑफ कस्टमर्स इज मोर, यू विल हैव टू क्रिएट एडिशनल सर्विस काउंटर्स. However, if the flow of customers is less, so you might have to reduce the service काउंटर्स। तो इन सभी प्रॉब्लम्स को डील करता है चैप्टर क्यूइंग थ्योरी, विच इज डीलिंग विद द ऑप्टिमाइजेशन ऑफ कॉस्ट्स रिलेटेड टू वेटिंग लाइन, which is also queuing theory is also dealing with calculation of waiting time of a customer in the system as well as waiting time in the queue, number of customers who are waiting in the queue and the number of customers who are waiting in the system. So this chapter is based on two variables, arrival rate and service rate. This was just a short overview on queuing theory. We are going to start with the practicals of queuing theory in the next class. There are many formulae which deals with the calculation of waiting time as well as to find out the number of customers in the system, thereby reducing the costs related to queuing theory. Right? So we are going to continue with their practicals in the next class. See you all in the next lecture.